Alright, welcome back Math 1 students. Today we're going to get into parallel lines and angle relationships with those. So to start us off, just a vocabulary word to start, is a line that crosses two or more other lines is called a transversal. So if you think of like transport, means to like go across. Transversal means to cross those two lines. In this diagram at right, which line is a transversal and which lines are parallel? So we have to name the lines. So we can see we have two parallel lines here, and this one crosses, it transverses the other two. So to name it, we're going to name it KJ. Line KJ is the transversal, and line LM is parallel to line NP. So normally we have tracing paper, and I have you do this yourself, but we're going to have to kind of do it a little bit different since we have this online learning. But we're going to trace angle X on tracing paper and shade its interior. So angle X is right here. Let me get a black marker, it will make it show up a little bit better. So we have angle X right here. And it says slide the tracing paper. So if you pretend we had a piece of paper over this, we're going to slide it up the transversal. So it's going to go up here, up this way, and it matches to angle B. We call that it corresponds to angle B. So if you slide it up the line, it matches angle B. So in the diagram, angle X and angle B are called corresponding angles. And what is the relationship between those two? What do you think? Do you think they add to 90 degrees? Do you think they add to 180, or do you think they are equal? So if you said they're equal, you would be correct. So corresponding angles are equal when the lines are parallel. So we're going to take this sort of parallel line relationship and use it going forward. So we're going to pretend, let's say angle B is 60 degrees. So angle B is up here. This angle is 60 degrees. What is the measurement of A, C, D, X, Y, Z, and W? So pause the video and see if you can find out the measurement of all these other angles. Unpause when you're ready. So here's what I got for my answers. And to find angle A, I know that it makes a straight line. So they have to add to 180. So 60 plus 120 is 180. The other thing we know is if B is 60, these are called vertical angles. They make V's with each other. So they're like opposite sides on that intersection, and those have to be equal. So we can use that property to find out the rest of those. And then again, if we slide B down to angle X, that's the same as that. Those have to add to 180, and just using that pattern all around the triangle. So Ashton wonders whether corresponding angles always have equal measures. So he said, is it always true? So for parts A through D, decide if corresponding angles have the same measure. Then, if you can, find X and Y. So if we look at these, if we look at this first one, if this angle is 135, that means this X is also 135. And if this is 135, we use a vertical angle to say Y is also 135. So that's true because the lines are parallel. But if you look at B, do you see how the lines are not parallel here? There's no markings to show they are. So we don't know what that X is, but we can find this angle Y right there. How do you think we do that? If you guessed saying these add to 180, you are correct. So we can just do 180 minus 135 gives us 45 degrees. Here the same deal, 135. That also has to be 135 because the lines are parallel. And then we can also say these make a straight line, so this is 45 degrees again. And over here, we cannot say anything because the lines aren't parallel, but we can still find x, where since it makes a straight line, that's also going to be 45. Next on our agenda is, let's pretend angle A is 48 degrees. So A right here is 48 degrees. How could we find angle B? So how could you like prove you know what angle B is instead of just guessing? So I want you to think about that for a little bit. How could you find angle B? What relationships would you use? And the way I would do it is I would say, okay, angle A slides down to this angle, so this has to be 48 degrees. And then since these are across from each other, these are opposite, these are vertical angles, B also has to be 48. A different way you might have been thinking about it, which is also acceptable, is you could say, okay, this angle is 48, since they're vertical, and then you can slide that angle down. Both are okay ways to explain that. So we have these things, and these are angle relationships, and we're going to study these a little bit. So I want you to determine if each pair of angles is supplementary. Do they add to 180? Are they complementary, meaning they add to 90? Or are they congruent, meaning they're equal? So pause the video and try to make a guess for 1, 2, and 3. So you're going to say A and B are blank for number 1, A and B are blank for number 2, and they are blank for number 3. All right. So you should have your guesses right now. And A and B here, well, if we slide B up, it matches right there. And we can see these two angles add to 180. If we're looking at number 2, these two angles, if we slide this one down, and then they're vertical, so they are congruent or equal. And then over here, we can slide angle A down to here, and we can see they add to 180. So supplementary for 1 and 3, and congruent for number 2. So the shaded angles in the diagram are congruent. So the shaded angle is here and here. And they are congruent. These are called alternate interior angles. So they're called alternate because they are on opposite sides of the transversal. So what that means is we have our transversal here, and they're on, one's on the left side, one's on the right side, so alternate. And then interior because they are inside the parallel lines. So we're going to first find another pair of alternate interior angles. So the other pair would be this angle and that angle. Those are opposite sides and inside the parallel lines. So I want you to write this down. If lines are parallel, then alternate interior angles are congruent. That's the big idea there. If the lines are parallel, then you can say they're congruent. Moving on. So we have another name of angles here. Here we have our transversal, our parallel lines, and then here we have those two angles. So these are called same side interior angles. Why do you think they have this name? I want you to think about that for a sec. So the same side means they are on the same side of the transversal. They're both on the right side. Interior means they are inside the parallel lines. So if lines are parallel, whoops, I just fell over there. If lines are parallel, then same side angles are, well, what's our relationship here? If we slide this angle up, that means those two angles add to 180. So we say supplementary which means they add to 180 degrees. And then we have another page here. So what I want us to do with this page, and we'll just start with the first two, and we'll do the second two later. So I'm going to put a shade down. Where's our shade here? So we can't quite see that yet. And over here we have 5x plus 55 and 2x plus 100. So over here we have 5x plus 55 and 2x plus 100, and here we have 5x minus 54 and 3x plus 16. So we're going to actually use some algebra to start solving these equations. So these angles, we have our transversal, and we have one angle, two angles. Now, what is the relationship between those two? Are they congruent? Do they add to 180 or do they add to 90? So if you said they add to 180, you are incorrect. If you said they are congruent, you would be correct. So our equation we're going to write here is 5x minus 54 equals 3x plus 16. I'm going to silence this thing so we don't get dinging. And we're going to solve that equation. So we're going to subtract 3x. We're going to add 54 to both sides. And we get 2x equals 70. Then we're going to divide by 2 to get x equals 35. On the right over here, if we slide this angle up, it matches up with that other angle. So that means these angles are congruent. So what we're going to write, 5x plus 55 equals 2x plus 100. I'm going to get rid of this 2x to make this, to get all the x's to the left side. And then I'm going to get rid of this 55 to get all our units to the right. So we get 3x equals 45. Divide by 3. And you get x equals 15. So those are two examples I did with you. But now you're going to try on your own. I want you just to do the first step where you're just writing the equation. So I want you to try to write the equation for both of these. So pause the video and try to write that equation. All right, so if you're ready to move on, if you wrote your equation, just that first step, we can see these two are same side, right? We have our transversal, they're on the same side, and they're interior angles. So our equation would be 2x plus 43, and same side interior angles add to 180. So plus 2x minus 3 equals 180. On the second one, these are vertical angles. Do you see how they make two V's? Vertical angles. We know vertical angles are congruent. So now pause the video again and try to solve these. So what I got is I got x equals 35 and 7 equals x, or x equals 7. The common mistake I would look out for is when we have x's on the same side of an equal sign, we need to combine those first. Same with 43 and negative 3. You need to combine those first before you start undoing. So check your work there. And if you're ready to move on, good job.